Content warning. This episode contains discussion about mental health. If you or someone you know needs help, help is available.
There's a famous quote by Jeff Hammerbacher who said, "The best minds of my generation are thinking about how to make people click ads." That sucks. And that could have been said about today's guest, Sergei Nozdrenkov, as well a few years ago. But not anymore. Sergei went from Google's moonshot factory to diving with sharks in Mexico, using artificial intelligence to save coral reefs. But Sergei Nozdrenkov's journey started much earlier, as a kid driving tractors in a small village, dreaming of building spaceships. Everything changed when he read a single science fiction book that connected two impossible worlds: the vastness of space and the mysteries of our oceans. That book planted a seed that would eventually grow into something extraordinary. Now, Sergei is building what he calls a nervous system for the planet, using AI not to sell ads, but to help ecosystems survive and thrive. Today, we explore how technology meets conservation, why hope matters more than perfect solutions, and what happens when you risk everything to work on the problems that scare you most. But now, I'd like to welcome you to Where the Ocean Meets, Sergei Nozdrenkov.
Where the ocean meets.
Welcome, Sergei. Very happy to speak with you today.
Hi, Joel. Good to see you. Hi, everyone.
Let's dive right in, and maybe you can tell me one thing about coral reefs that would blow people's mind if they knew it.
Oh, like recently I saw some video where a coral reef eats some fish apparently. So the fish fell and there's like certain species of coral which could like effectively dissolve this fish. So that was wild to me. I like never knew that they could do that. So there was like some crazy coral, and I sent it to a few scientists, and they were like as well like surprised. But well, some of them knew this, and some of them didn't. So I was like, wow, that's crazy.
It's funny. Yeah, I have to admit that only at the UN Ocean Conference I learned that coral are actually animals and not plants.
Oh, I think it's like complicated. So it's a symbiosis between like photosynthetic algae, like zooxanthellae, and like animals like polyps. But also, I'm like not an ecologist. I have zero authority to tell what it is exactly. They're like,
So
like creatures.
I wasn't completely wrong thinking that it could also be a plant.
Yeah.
Okay, that's good.
South plant, almost.
But the corals might be a bit of a foreshadowing of what we're going to talk about a bit later. But I want to start way earlier. And actually, I read that you grew up in a small village, and my understanding is quite far away from the ocean. What is it that does draw you to the water?
Wow, that's a great question. I don't know even like where did you read this? I should check the sources. But uh, yeah, so I did grow up in a small village. I used to drive like tractor when I was a kid, and uh, yeah, so I didn't really like appreciate much being like in nature, like because you have to look after like potato or like tomatoes all the time and so on. So I tried to escape into the big city later, which happened, and we didn't really have oceans nearby. So I think I learned how to swim when I was maybe around like 13. So that was the first time when I went to the sea, and I wouldn't say that it was like life changing or something still. So, but at some point, I think uh, so. I always was like driven to like technologies or of some sort. So, for example, I was dreaming to become like an engineer who builds like airplanes or like spaceships and so on. So, I was reading a lot of science fiction, and there's like famous book called like Space Odyssey, like a few books by author Charles Clarke. So the same guy wrote another book which called The Deep Range, and I read it at some point. It was like a story which so there was like some uh I don't want to like spoil the story, but basically there was like some really cool engineer working on the like missions to Mars, and there was like something bad happened to him in space, so he ended up somewhere in like Indonesia or like French Polynesia, working in the like research center like underwater, and it was a cool dude and great engineer, and there was lots of adventures underwater. And it effectively, this book, when I read it, I was like, wow, actually space and the ocean, they're like almost the same thing, but ocean seems to be so much cooler because like so many challenges and we still don't know anything about it. And it's both hard from engineering perspective and like a lot of cool adventures could be there. So when I read this book, I was like, I don't know, like shocked. So those two worlds connected to me. So I always wanted to try maybe like scuba diving or something like that. So in 2016, I was trying my first scuba diving somewhere like Thailand, and it was like a regular Discover Scuba. So the instructor was like holding my hand all the time, and I was thinking I'm gonna die right now, but I felt like a Darth Vader at the end or something, like breathing this. And then I remember when we like surfaced after like a fairly short dive, he was like, "You can take away the regulator," and I was like, "No, no, I paid for this oxygen." So that was like very early days, but then uh, I don't know, it felt like surreal, and so I wanted to try like again. So I did like a regular like open water diver course. And then like it felt like so cool because I barely could swim, and kind of I sink quite well. So I thought I should work on my strength and like sink better. And yeah, then I effectively did like advanced, then did lots of dives in like dry suit, for example, in Iceland to see this like silfra, and like it's a mega crack between like tectonic plates which split the continent into like Eurasian or uh, American part of the world, and it's like 70 meters deep in the deepest place, and you could see maybe 200 meters in front of you. So that felt so cool. And then like started doing like free diving and so on. So yeah, basically after that the ocean became part of my life, I think.
I love that, from reading a story, a book, to learning swimming, to then going on to a hardcore dives. Like, that sounds like a um, fascinating journey.
Yeah,
I
I think just to add to this, I've met lots of people who like still maybe they're like adults, but they're like afraid to dive or or just to swim, or they feel like very claustrophobic maybe underwater. And I could actually relate to a lot of those things. And I've seen some of those like people overcome those fears, and after that they love oceans the most, so even more than people who for whom it was like very natural and like easy. So I actually feel it's kind of if you go there, it's like it becomes your like superpower, because like you couldn't um, kind of overcome it in the past, and it feels scary, but now you do it, you like feel so ecstatic. So I would definitely recommend to people who never did it because they're afraid, to give it a try.
think that's something very special about the ocean, right? That it's so scary and it just humbles you so regularly. But then if you get in sync with it, it feels like magic. And what I loved most about diving was this being neutrally buoyant and like basically just floating underwater. And it felt like no gravity exists, none of that. It's You can steer where you are with your breath. It is crazy. But I mean, if I researched you online and I saw you have so many interests, like you're a software engineer, you blog on a lot of different topics. You actually started an apnea diving club in central London. I don't even know where you can dive there. You started your own company now and you do angel investments. There is a lot of curiosity and bias to action. And we briefly talked about your childhood. Is there anything, like, if you think back to your childhood and look at your life today, are there parts in your life where little Sergei would find excitement, where he would say is like, I'm proud of my older self. I'm excited about my life today.
Hmm. That's a deep question. Uh, yeah, I guess like the youngest Sergey like wouldn't probably believe like where I ended up like later, and probably would be proud. But like as you grow and like improve, your baseline drops, and then you don't appreciate anymore like where you are and so on. I think that's fine, and I also don't like kind of to hold back on the like old things and like, oh, I'm this type of person, this is my identity, yada yada. It's always good to start with like V0 kind of mindset where you uh, kind of, it's very uncomfortable go back into somewhere where you have to like learn a lot and so on, but I feel that's the best actually way to grow. So now I'm like almost like homeless because of doing the ocean startup, and yeah, I'm not sure if the young version of myself would believe I will be like almost homeless in the future, but probably would be proud for like taking action and like I don't know, going there.
Yeah, from farming potatoes to the UN Ocean Conference in Nice is a long way. And actually, we talked about your childhood, and now at least on paper you are a grown up. And when we first met, um, we never talked about our businesses, which I loved, and I loved the kind of questions that we played around with, and that made me think of, if you had a color and an animal to describe your career, your life to date, what would that combination be?
Hmm. A career and a life at the same time.
Let's focus on the career, because I find that quite interesting.
Some stupid animal, but they're like smarter than me. Maybe a bunch of like bees, or like which make a beehive, or like ants, which kind of try to build something, like work as a swarm intelligence, try to do something here, something there, and then like everything works here and there. And then in terms of color, mm, maybe like warm orange color. Yeah.
Okay, yeah, that sounds interesting. Orange ants. Let's take that as an animal. Because if we talk about career, right, you, I think in tech, held one of the most prestigious roles that an engineer can get. Like, you were working in Google's moonshot factory, Google X. And I don't want to talk too much about that, but actually about the moment when it ended. It's your last day, you're entering the Google office, you hand over your computer and turn around to leave. You make the decision to start your own company. Can you tell me what was on your mind in that moment when you put everything down and left that office for the last time?
Yeah, that's actually was like terrifying at the same time, and uh, I would say yeah, more terrifying than exciting. Actually, so kind of both. I feel yeah. So it's yeah. I think basically when I was like leaving, there was like kind of one intention on like why and like what needed to happen. Then this thing changed a lot, so I was like basically not sure what would be like next, and I knew that okay, it's time to leave and like change the chapter, but it was also very like extremely uncertain what's gonna be next, and I had lots of anxiety. I got like my first panic attack as well, and yeah, I think back then was like one of the most difficult things in my life, like that year specifically. I think everything like collided all at once. So like me like leaving the job and like try to do like something next. Plus like I had like some problems like in the family at the same time. Plus. Like uncertain. So I realized that like my work is like whatever I'm working towards is like part of my identity. And then once you lose it, it's like you feel like a bit depressed and so on. And so like all those things we started kind of to bubble up, and Yeah, I moved from like my favorite flat, which I put like lots of effort, like decorating and so on. And yeah, it was challenging, but I think yeah, what doesn't kill us puts us on lifelong medications. So so I'm still alive and moving forward. So, but that was like definitely like terrible. So yeah, I guess. The most terrible is like a feeling of like uncertainty because you kind of already got used to going to the same office for like many years, like having a nice life and so on, and then you're trying something new and you are like not even sure what exactly it's gonna be. So that was like terrible. So I started like writing down things, for example. So I knew like a few directions where I wanted to go, but like I didn't know what exactly would it be. So I wrote down, let's say, 10 different areas what I liked, and then like asked myself, why did I like this? kind of, or like multiple times, and then it turns out that they all kind of had the same ish route. So I started working towards that, and that gave me.
What was that route?
It's more like understanding like secrets of life or like decoding nature and or like biology or like I don't know, like intelligence, and then so that we could apply them as well elsewhere, like for example to make something useful. So it basically was like around curiosity, how the universe works, specifically I guess biology but maybe at scale, and yeah, how to apply it in the real world so that we could get something out of this. So if it was just curiosity but like useless, that would be less interesting. But I guess it's a definition of power. But I'm scared to say like power because it could be like I don't know, like some politicians types of powers. That's I'm like not really like interested in something like that. So more like engineering power or like a creative power. So you could really like understand some algorithm, for example, and while now you could like go and change the world with a like better algorithm to I don't know, like matrix multiplication or something. So same is here. What I do now is like, let's understand how nature works. We could learn so much from it, and then we could use those like to, let's say, align human activities with our understanding of nature. So that's roughly was where it is.
Yeah. So to create and explore, basically, there seems to be a strong pattern.
Mm-hmm.
And the other thing is putting yourself in uncomfortable positions, huh? Or things that frightened you, and then
Yeah,
embrace it.
I mean, everyone goes probably through something like that. So if you go through episode like that, it's okay. It's really hard to be a human. So, but you'll get there. It's gonna be good.
But I mean, in the end, it was a good, like that feeling when you walked out of the Google office was probably a good precursor to startup life, where you constantly have these worries and doubts and highs and lows and so much change. Explain to me what you do today.
Okay. Well, we are modeling like natural ecosystems. So this like life on Earth is like incredible. It's been like evolving for billions of years, and uh, again, like we could learn so much from it. And we don't really like understand how natural ecosystems work, and like lack of understanding leads to like poor decisions, and then we effectively like harm nature. So the plan is, let's understand how natural ecosystems work so that we could align human activities with our understanding. So there's lots of scientists processing nature data, and I'm helping them with data infrastructure so that we could make those decisions quicker, faster, and like more quality decisions. But starting with the coral reefs ecosystems, and specifically with 3D photogrammetry data. So, for example, someone could swim with a few cheap cameras like GoPros around like coral reef, and then we turn it into high resolution 3D models visible in the browser, so you could like share it with other friend researchers and see how, for example, coral like changes over time, like before or after. like restoration, for example. You wouldn't believe that, let's say, in Indonesia, in 84% of coral reef restoration cases, there's like famous treatises paper on the topic, uh, that like people never come back to monitor those reefs like at all. Well, because it's expensive and so on. So nobody really knows like which methods works best, because everyone is claiming like we are the best, give us the money and so on. So we don't really know like what works, what doesn't work, and there's lots of people who monitor, like started to collect the data, but all this data is like fragmented across different organizations, different formats. So there's like no way to properly to take all this data together and make some sort of quality decisions from this data.
Mhm. Interesting. And I read that you took part in a conservation project or shark conservation project in Mexico. I think that was before you actually started the company. Did that in any way, like being part of such a conservation project, inspire what you do today, or how did you come to the idea?
That was like really, yeah, exciting experience, and I learned a lot from this. Again, you did such a good research. I don't even know where you get all this information, but yes. So I did start the company first, but like not officially, not registered. But I was already on the journey towards, I guess, this mountain that we're trying to tackle right now. I just tried the different approaches, and they were like inspired by my previous work at Google X. So basically, I was trying to create like a platform for like biodiversity data in the oceans, like mainly time series geospatial biodiversity data, so similar to GBIF, Global Biodiversity Information Facility. So it's basically location, time, who was there, how many was there, and putting together these types of tabular data and helping to like analyze it. This is very similar to what I did in the past when I worked on like pest outbreaks and these kind of things. And uh, so I spent like about a month with Pelagios Cacunha in La Paz in Baja California Sur. That was like really, yeah, like exciting time to work alongside with researchers, because I kind of could like understand what is happening there and so on. And there is a lot of small NGOs around the world who doing like the majority of like conservation work, and they're like one of the best NGOs who is protecting like different like marine protected areas like Archipelago de Revillagigedo and so on. So that they taught me like lots of staggering like facts. For example, it takes at least 5 years to create new marine protected areas, and like I'm like crazy. And apparently, if you even if you have all the data, it takes you, let's say, a few years to process all of this data. And I was like, wow, that's crazy. How could it be like that long? Like, why it's not like an hour or like a minute, like and so on. So I started like,
Coming from the place that structures all the world's information and makes it
yeah.
accessible.
I mean, I understand because they're like, let's say, underfunded and so on. But yeah, so could we build those tools and like scale them across the world so they are like empowered to do those things faster? So effectively, I started looking what are the bottlenecks there, and like I guess identified a few and tried to figure out like how do we resolve them. And yeah, that was like very interesting experience overall. And I kind of like the first year, so I left 2.5 years ago. So the first year was about kind of exploring different kind of landscape of opportunities, what is there in the ocean. So I looked a little bit at coral reefs, but like not much. Then I looked at aquaculture, looked at let's say creation of marine protected areas. That was the main focus. Then looked at like different like oyster reefs, or deep sea mining, like where the devils are, or like a BP shell extracting some sort of like lithium and those things, and like just try to understand what's the problems and how we could solve them. And effectively, like after 1 year, I got the idea like where I want to go. So basically, at the beginning, like someone, like a friend, recommended me when I was leaving. It was like try ikigai. It's a like famous concept of, let's say, do. It's like Venn diagram between like do what you are good at, do what the world needs from you, and what people could pay you for, and what you really want to do as well. So it's like you need to be kind of in the middle. And then after this year, so I feel like I was always in the area where I tried to be at something where I'm good at, but less on the where I want to be going or something.
Mhm.
And then I dial it. So the big breakthrough came when I focused on what I want to be going and less on what I can't do, because I realized that you don't really know what you are capable of. So let's just focus on what you want to be doing rather than like this. So I have now ikigai in my head, but with a bias towards what I want to be doing from the what I could do. But
Yeah.
um,
What,
yeah.
what does the center of your ikigai now looks like?
Uh,
Would you say Wildflow is there already?
oh yeah, 100%. Like yeah, it's so I think so. Basically, after a year, I realized where I want to go, and then like April last year or like May last year, I realized how I want to go. So now I'm like just trying to go there, but yeah, so it's less uncertain, just challenging. So in terms of like where I want to go, I think so how I think is like better to have like A plus problems and B minus execution is better than B minus problems and A plus execution. So I thought, what would it be ultimately if I were to like meditate on it, and like what does it mean? So I think ultimately at some point, or it is the big goal of all of us, is like trying to achieve, all of us, I mean, in this field of ecology and so on, is like how do we become the first generation that leaves nature behind better than we found it. And I feel there's two parts of the problem effectively. First one, we need to know what to do, and then the second one, we need to do what we need to do. So first one is around like kind of understanding the complexities of nature, because it's so complex, and if we do something that we don't like understand, we ruin things. Like look at like rabbits in like Australia and so on. So basically the first part is around like modeling biosphere, all the ecosystems, and the second is around aligning human activities with our understanding of nature. And I think both problems are like very important. And yeah, so I'm effectively pursuing the first one, and I think we already like modeling biosphere to a certain extent and like coordinating action, but I feel we could do way better. So there is some statistics that shows us that nature gives us like $40 trillion a year, which is more than the global GDP in terms of ecosystem services. So I believe that if we optimize our decisions by just like 1%, that would be over $1 trillion value. So there's like this is more like for investors, like a financial part of the equation, because like nature really like gives us so much, and we, instead of like destroying it and like exploiting, we could just align what we do and get more value. But I think I would need to give you like later like some concrete examples because otherwise
Wait, if we dive into that a bit, because I now understand like you take different data, right? It's like I read that it's not just actually imagery, but also bioacoustic microphones, eDNA, a lot of sensory data that goes into your model. What can you do with it?
Yes, so let me give you examples from like different areas so that it kind of fuses the kind of picture together. So first one is like from my previous job, because it like influenced me a lot. So one thing we did, we were like listening for bees, buzzing, using different like IoT devices, and then trying to use machine learning to classify diseases of the bees, or like, are there any like ants in the colonies and like this kind of things, or where do you place beehives for better pollination? So effectively, you can, that's one way how you could like use kind of intelligence to to do something there. Then second, it was pest management. So we had a whole bunch of sensing solutions measuring where different insects are in space and time, like pheromone traps or like linear irrigation systems with cameras and so on. And then we were modeling population dynamics of insects, so like predicting when the outbreak is going to happen, so that we could do some sort of actions in the real world to manage this. So for example, simplest one would be, instead of spraying the whole field, you could spray only a small patch but a few days earlier, so that you don't use the like pesticides, but or like use less of them, because use of pesticides is the biggest driver of biodiversity decline in the world of insects. So that's important. Or there is like completely other strategies people do. So for example, there is like mating disruption strategies. So let's say insects communicate through like pheromones or like semiochemicals. So there's like people who like basically, let's say a female lays eggs somewhere and then male wants to fertilize them, and they find them by smell. So if you can confuse them, let's say if it smells everywhere the same, they wouldn't know where the actual eggs are, where it's just the smell. So it's effectively population declines, and you don't need any pesticides at all. And the same things people do now, for example, for crown of thorns starfish. It's like animal which destroys, let's say, coral reefs if it's too much of this animal, even though it's like very important part of the ecosystem. When it's out of balance, this is what's happening. So this is a few examples. There is like very famous examples about wolves in Yellowstone. Have you heard of this one?
I heard that people talked about wolves coming back, and I just read the news. Like, obviously there's pro and con to that in people's minds, but I didn't ever go into detail. I heard about the Yellowstone story.
So what we covered was like population dynamics mainly, and population dynamics is just one way of like modeling what's happening in nature. For example, algal bloom is also population dynamics of just algae instead of Colorado potato beetle. And then there is like other types of dynamics, for example, predator-prey dynamics, or like energy transfer, or like trophic cascade of things. So for example, in 1920s, all the wolves in Yellowstone were like completely hunted down, and the ecosystem was out of balance. So in 1990s, scientists tried to reintroduce, I don't know, like 100 or a few hundred wolves back to the Yellowstone from Canada, and it was like very controversial. People were like, no, we don't need the wolves, yada yada. So basically within 10 years, what happened is wolves started like chasing deer or elk. There was like so much elk, and elk were overgrazing all the trees, so trees became more healthy because the population like changed a little bit, and the behavior changed. And because trees were more healthy, when was the rain, all this like moisture started to kind of concentrate there. So there was like a microclimate over there, and the creeks started to appear. Once there were creeks, beavers came and started making dams, and those creeks became like rivers effectively. And so in basically on one side you deploy, let's say, 200 wolves or 300 wolves, and then on the other side, in less than in 10 years, you have rivers full of water, and the population of like bears goes back to normal, and like a whole bunch of other species could live in the rivers. So this is called predator-prey dynamics, and ecologists could model all of that, and they just do this kind of slowly and like using old school technology. Imagine if we could take this type of scenario and like scale it 1,000 times across the globe, and then like all others, like for the pest management, or for how we manage algal blooms, how we protect and create like marine protected areas. So basically there is lots of lots of actions which we could do, and the actions could be global ones, like which we all know, let's say removing like plastic, that's super important, or like reducing carbon, which is super important, and so on. But also there is lots of those localized decisions which only work if you know what to do and like work in a specific scenario. For example, like deploying 300 wolves, and some of those could be hard to control, like rabbits in Australia is like better not do this, and some of them actually could be relatively easy to control, and we could do all of them if we know what needs to be done. So effectively what I'm trying to do is create some sort of like intelligence which will help scientists to process their data faster and understand better what's happening there. So my dream case scenario long term would be, imagine you have a forest, so we take data from all the sensors measuring it and create some sort of like virtual representation so that we know where forest experiences pain, or where do you need to deploy 300 wolves to have rivers full of water, and so on, so that we can keep the forest healthy and like strong, and so on. And basically I see that amount of nature data is skyrocketing. At the same time we're losing nature, and also AI and technology is improving. And if you look back at when the internet appeared, we had a whole bunch of websites, and you could maybe remember like 100 websites, but basically um, like search engines like Yahoo, Google, Bing, they were destined to appear because you need to make use of all of this data. Otherwise, it's like useless, just sitting there and like, and so on. So same as here, amount of nature data is skyrocketing, and we need to make it useful. But the way to make it useful is not about search; it's about fusing together different streams of data, understanding what's happening in natural ecosystems, and then creating kind of quality decisions on top, on like what actions needs to be done in the real world, so that we could basically have protect and restore it quicker. So that's long-term vision. And I was thinking, what's the quickest path towards like modeling the whole biosphere? So I'm sure we will model it soon, or like sooner or later, maybe in 100 years, maybe in 10 years, but we're going there because getting more data, like better capabilities to do this, and we need this. So I was thinking, where do I start? And my big bet is on foundation models, on like AI, because it was like changing, like improving quite a lot. And in the past few years, we have like really big breakthroughs. For example, people building like foundation models for like robots, or self-driving cars, for physics, for like chemistry, for medicine, and so on, but like not really doing this for ecology. But think like self-driving cars, like you take data from multiple sensors, fuse it together, understand where you are, turn it into some sort of actions like turn left, turn right, accelerate, indicate, and you get to some sort of a destination. So same with managing like natural ecosystems. So we need to process all this multimodal data, understand what's happening in nature, and like drive those actions of what needs to be done. And I was thinking, where do we start? So I realized actually we should start somewhere where it's a small niche where we could test all of these hypotheses. And this niche needs to have lots of where we could learn the most effectively. So because if we were to start in agriculture, there's only a few crops, few pests. But like coral reefs, they're like 0.1% of the ocean, the size of New Zealand, but they support quarter of marine life, 500 million people depend on them. So they're like really beautiful and incredibly complex. So if we train those models there and like help optimizing those decisions, then we could go and like apply them elsewhere in like other ecosystems. So that's why basically I'm like doing coral reefs. And the 3D modality is just a starting point. It gives like signal, like larger signal to noise ratio effectively.
Okay, that sounds fascinating, because I think the work on the coral is incredibly important, and um, I read that we're on track to lose 90% of coral by 2050, basically. Do you see anything in the data, anything that you do in your day-to-day that gives you hope that this train can be stopped?
Mm-hmm. Well, it's true that it's a like very sad field to work on because you see what is happening and so on. But I think it's still worth giving it a shot.
That for sure.
Because
Yeah.
so again, like we could split different like interventions or decisions or like even stressors. People usually split them into global threats for coral reefs and like local threats for coral reefs, and it's very easy to take no action and say, well, while the water is like warmer because of climate change, we're not gonna do like we're not gonna give a shit at all about what's happening locally, and like not gonna take action because it doesn't really matter. I don't think that that is the truth. Maybe it's a truth to a certain extent. Well, maybe we could, because of the global threats, maybe we would lose 30% of corals, but like not like 90. So I think there's a still huge like a chunk of things that we could do locally so that we could protect them. Are we doing enough? Clearly not. So we need to do more. There was like even like Nature paper which was showing that like restoration is like almost like useless and so on, and it's not like a surprise to me because yeah, we don't really like monitor, like you can manage something you could measure, and we don't really like monitor them except like humans like swimming there and like writing down on paper what's happening, and like in the best case scenario people have like photo quadrats taking pictures on something, or maybe like eDNA, but that's really like not scalable and sustainable. But I think there is still a lot of like amazing people fighting for that, and there is still a lot of money which is waiting to be deployed into coral reefs. It's just nobody wants to give them because like you don't really know like what's the return on investment, so you give it to some project and they just wasted it and restored it like only a small patch, so why would you give it? So I think we need to have like a better coordination mechanism overall, so like knowing what methods work, what methods don't work, so that all those money will be deployed faster and then we'll like restore reefs. I think it's a very hard problem, but I personally believe that it is possible and that there is like hope.
I think the moment we lose hope, we are lost. So
Yeah. I think let's just fight and then
yeah, exactly.
regard
There's this quote that I love so much, and yet I can't remember it word by word. It goes something along the lines of, hope is not the conviction that something will end well. Hope is the conviction that what we do is important no matter what. And
Yeah.
that kind of gives me a lot of ease of mind, because I know it's like as long as I keep working on the problem that I find important to work on, there's hope.
Yes,
Yeah,
exactly.
right? One moment you read the story about the ocean in your small village, and the next moment you're diving with sharks in Baja California. So you never know where life takes you from a single decision or from a single point of information.
Yeah.
Yeah.
I was thinking like around like April last year, so I had like multiple directions where to go with this. So there were like some directions which had a little bit more money, like for the startup is better. Then some directions where I was good at, and then like those 3D corals, I realized, oh, actually that's reasonable, but like there's no money there, and there's like I don't know anything about this, and like I used to work with 3D like 9 years ago at like Google, and I'm not sure I want to do it because it was hard. But then I've heard like another prompt question which might be useful to other people is like, imagine you have like 5 different or like 10 different directions, which one you would still do if you were to fail in all of them. And I was like, oh, actually, if I'm gonna fail at all of them, I would still do this one because it seems to be like interesting and like would like be important. So that's how I chose it, and like moving forward. And then one more thing that I'm always thinking about is one way to think about is um, like let's say something. So like think of this as a problem, and you're like, this is again like a problem. We need to restore them, but like we're like not restoring them. But you could think from a positive mindset. Like imagine we did restore this, and then there was like lots of side effects. We learned so much, and then we could go and like fix other ecosystems and like restore them, and then we again like learn so much, and like we model the whole biosphere. We kind of living in a paradise where humanity and like nature is not like a plain zero sum game where we extract from nature, but rather like a symbiotic relationship, and like building growing pie, and like enriching each other, and like and then we can go and like maybe terraform Mars and like yeah, build the jungle there. I don't know, lots of people from ecology or like conservation people would hate me for that, but I feel there is like lots of actually exciting things about doing this. So yeah, that's what driving me forward.
Nice, very interesting. And maybe you can build a highway for Mr. Musk to his Mars.
Well, yeah, Mr. Musk is we'll see.
different topic. Now your first product is focused on coral for all the right reasons, I believe. And I remember I was once in Senegal on a surf trip, and there were a lot of sea urchins, and there was one marine biologist that told me about his dream, basically that there is a model, because I was like, if only there would be no sea urchins. And he says like, well, if you take the sea urchins out of the ecosystem, this and this and this could happen. It would be so nice if we could just extrapolate and see what the world would look like in such a scenario, right? Am I understanding your platform right, that if you are successful, scenarios like this can be modeled? It's almost like the metaverse where you say, it's like, okay, if I take this
Uh-huh.
door, what will the world look like? If I take this, what will the world look like?
I think that would be great, like ultimately to do this. But again, this type of scenario. So I guess this is the kind of definition of like digital twins. So you could say, okay, let's model different what if scenarios and see what's gonna happen. Some people like it, some people don't, because I think yeah, there's two ways to think about this. So there's like old school kind of digital twins. There's like where people try to put too much hype into it and it doesn't work. So it's like something in academia where there's lots of I don't know, observational data, but it's not like really a ground truth, and it's like doesn't really drive action and doesn't move anywhere, and it only can do things that we could like program it to do. So yeah, that's not like fantastic. And but then there is a kind of new so I think new models like AI, they it has like ability to generalize things quite well. So we could learn a lot by fusing all this like data together and like making those quality decisions. Uh, but the way to think about it is also like I wouldn't try to go into like science fiction first. I would think of like, oh, let's look at existing workflows of ecologists, what they're currently doing, and then we could like accelerate that. That would be already like much faster. So, for example, instead of creating marine protected area like 5 years, you could do it, I don't know, like maybe in 1 year or like quicker. That would be already like a big jump. Then second is like, what if we like there is a lot of information loss from sensors to the actions. I could even like give a few examples. So for example, you had like a video camera underwater, and then use let's say BROVs, it's called like bited remote or something, underwater video cameras underwater. So that's how they, let's say, track sharks. And you have a like kind of bite, so the shark would swim and like try to eat it. And then like ecologists watch all this data, usually like manually. Now there's a little bit of like YOLO AI models, or like some sort of simple solutions to find this.
YOLO AI model.
Oh, okay. So
Some kids grow up and
no, so YOLO is like really cool architecture, but it's not modern. I would say it's from, I don't know, like maybe like 5 years back, which is um, it's called You Only Looks Once. It's That's why it's called like that, and it's let's say everywhere in let's say detection, or maybe detection of objects on the video camera. Like people use those. It's similar to ResNet, but like usually like maybe faster, and um, it's not fantastic in terms of like current modern transformer based architectures, in terms of like understanding what's happening at the scene and so on, but it's very easy to scale so that you could do this. So some people use it for even like geospatial data, like let's say uh, yeah, like detecting, let's say, ships from the satellite data. So let's say you see, okay, this is the shark, and what you do, you usually put this information into like some sort of spreadsheet where you would write, let's say, in this location, in this moment in time, we had this shark, this was the size, and that's it. And then downstream ecologists would take this spreadsheet and then use it for whatever, like ecological niche modeling or like other types of modeling. But the problem is that and we could do it elsewhere. So it's like roughly works like that. So you take data from sensors, then you throw away all the like information except the ones that you seem reasonable at the time, and then like put it to a spreadsheet, and then like take this spreadsheet and into another spreadsheet, and then at some point there is decision maker who sees and like, yeah, let's do this. So what I see, the problem is, like, for example, for certain there is like well-known thing is like how close let's say a certain fish to the camera person. It could tell you, like, for a certain species it could tell you about threats, of human threats on the ecosystems, like whether people harassing fish or not. So basically distance, how or like proximity of the fish to certain cameras, it could play a role. It's not a role in the shark case, but that's a bit of information in like similar types of systems. For the sharks, maybe you catched on the camera, like if it was hunting someone, or maybe there is like some sort of like tissue loss on the, I don't know, it's diseased, or there is a hook on top. So all of this, I think, would be like lost downstream. Maybe people would notice, but then they maybe like wouldn't write it, or something. And effectively downstream decisions, it doesn't really like change anything. But I think with current, let's say, AI models, instead of emitting you, let's say, three values like latitude, longitude, who was there, and like, or like width, or like length of the shark, or like biomass, you could actually emit like, I don't know, 50,000 values, which would tell you like, oh, this is there was also algae over there, and like I don't know, a shark was like funky. I looked at millions of sharks in the world, and I noticed that this shark is like moving weirdly, so it has like checkbox and so on. So it's called embedding.
there's a cramp in his back and can't swim right there.
Exactly. So you could get so much more information, and then if you want to like have another model which would take all those, let's say, embeddings, and then like find something from them, that would be super valuable. So this already works a lot. That's how let's say if you talk to ChatGPT, it has like whole bunch of like memory kind of in the chat. So let's say you could pull up data from previous chats. So they maybe use some sort of uh, I don't know, vector storage for those like types of embeddings on your data. But we don't really do this in like ecology. We're like losing a lot of information. So basically we could do it faster, we could do it in a more clever way, and I think there is way to get there. I think of this as like a nervous system for the planet. So for your nervous system, let's say you touch something hot, you measured this, then you like understood, like, oh, like, or not even understood, but like your nervous system got it, it's like hot, and then you take action, you remove your hand. But then in nature we do the same. Let's say you measured where the sharks are, then you go and like figure out where the cluster of the most important fish you want to protect, and then you establish marine protected area. So, but for you, it takes a second to react, or maybe less, and there it takes like 5 years, which is like crazy. So, how do we first of all like accelerate this nervous system so that like it's quicker, and then the second is how do we make it smarter so that next time you see, for example, something hot, you are like, I'm not gonna touch it. So same here is like you have data from the sensors, and we kind of could learn from it, and then we, I don't know, do different actions so that we kind of, I don't know. So think like digital nervous system for the planet, where we take data from all the sensors measured in biosphere. Then all this information goes into some sort of distributed brains, and then we take action back in the real world and like do this fast. So if someone is, I don't know, uh, killing like turtles somewhere and they're like dying because of some reason, we could react way quicker and like come back next day and like start fixing the problem rather than waiting for like 10 years until they're all extinct.
So yeah, you gave me hope on so many dimensions, like hope for healthier coral reefs, but also that AI can be used for good. I think this is one of the first conversations that I heard in a long time that is not about how AI is gonna kill me. I'm in the wrong bubbles there, but I really truly hope you will be so successful with it. And before we wrap up completely, I'd like to do a quick rapid fire with you.
Yeah.
Rapid fire.
Start with we were just hopeful, but I want to go to one place again. What's your biggest fear about the ocean?
That we're gonna lose it, I think.
If you could have dinner with any marine animal, extinct or alive, which one would it be? You would obviously speak the language of it.
Well, I think octopus would be the ones because they're like so smart and yeah, phenomenal animals. But
And they have 8 arms to steal your food, so it's
yeah. Oh, that's okay. Maybe let's do jellyfish, like chill but dangerous.
What's the most beautiful thing you've seen underwater?
Kind of so many like, well, coral reefs with like some sort of small venomous snakes. So I remember I was like mapping coral reefs in Indonesia, and I was like, wow, such a beautiful creature. And then I was like, why is it swimming onto me? So like, but then I showed the pictures to the friends, and they're like, well, this is actually really, really venomous. But that was a beautiful thing.
When you're stressed about the future, what do you do?
Mm. Well, I think it's good to like meditate why you feel stress, and then once you get to the point, like maybe it's a feeling of being uh, kind of hopeless, or that you cannot do anything. And I think yeah, like I don't see any like laws of physics which tells us we cannot sort this mess. So I think it's all about like us taking actions, but it's not clear which action to take. So I'm working on like trying to figure it out, but and that reduces my anxiety for sure. So
Mm. And then, since we're on a high note, I think this would be fantastic if it would ever work. What's your prediction for when we'll first meaningfully communicate with whales?
mm, meaningfully, I think that's a good definition, because it feels like in some sense we're already kind of communicating to them. This like really cool book called How to Speak Whale about the whole problem by Tom Marcel. Uh, and there is like a few projects, species projects, and project SETI, like search for extraterrestrial, I think, activities. So there is a few projects effectively trying to decode whales speaking. Um, okay, let's say in a few years, within the next maybe 5 years, but I don't know what would be like meaningful. We could tell them like, run away, guys, like, yeah, we are crazy, but we will try to fix ourselves. And they're like, okay, please do it a
Well,
bit quicker.
we've seen that before. So,
Yeah.
no, fantastic. The moment that happens, we have to jump back on. It was fantastic having you. Thank you so much for taking the time.
Great, Thomas. Thank you so much, Joel, for having me. It's an honor.
Where the ocean meets,